Okay, hello, good evening. This is group one for our group activity number 3. My name's Olivia. I'm the chairperson for this week's group activity. And we are focusing on our Clover Learning assessment, which we are all going to go over as a group. And we were assigned the X-ray production and safety assessment, but mostly geared towards X-ray production, as you can see here on the screen. And we're just going to go through it as a whole, all 7 of us, and I will call on us each individually, but we will also just help each other out and get through this smoothly. So let's start. Okay, so for the first question, I will just start. So during an X-ray exposure, an incident electron strikes the anode with an energy of 110 kilo electron volts keV and passes very close to the tungsten nucleus. What is the approximate energy of the photon created by the interaction? So for this one, I believe I did already take it. Um, so I put 110 keV. I'm not sure if that is correct, but
I
I
agree.
should be. Number 2, Willie, this is your question to answer. I'll have you read it and answer it.
All right. It's the energy of Bremsstrahlung photon is dependent on which 2 of the following variables. Select 2. And it would be energy of the incident electron and the proximity of the incident electron.
Okay. Next, we have question number 3. Heidi, you will be doing this question.
Okay. The most useful characteristic X-ray photons are produced when incident electrons interact with which of the following? I believe it's the inertial electrons.
I agree.
I hope.
Okay. Number 4, Viviana, this is your question.
Okay, so what technical factor is responsible for accelerating electrons through the X-ray tube? I believe it's the KVP. Do you guys agree?
Because I always remember, I think it was Professor Scolari or Chuck, that he said like it's like tennis balls, like the power and the energy of how you're throwing the tennis balls would be the KVP, whereas the quantity, like the amount, is MA. So I always think of that. Number 5, Angela, this is your question to read and answer.
Okay, it says which 3 of the following are required for X-ray production? And it would be source of electrons, means of rapidly accelerating electrons, and means of rapidly decelerating electrons.
Okay. Jessica, number 6 is yours.
Thermionic emission is the process within the X-ray tube directly responsible for creating, I think I put free electrons.
Mm-hmm.
Yeah.
Okay. Number 7, excuse me, Danae, this one is yours to answer, and then I think it does require a little bit of math.
Okay. During an X-ray exposure, an incident electron strikes the anode with an energy of 90 keV and passes very far from the tungsten nucleus. The resulting photon energy is 30 keV. What is the approximate energy of this electron as it exits the atom? So this one, I think I got wrong, to be honest. I'm not really sure on this one. Okay, so the other one, it was 110. Let's see.
So Danae, for this one,
Mhm.
if I'm correct, because I got it, since I did the videos, I think that question was also on there.
Yeah.
So the 90 electron volts is what it starts with, and then it results in the energy of 30 that gets used. So you would just subtract the difference. So I
So it would be
believe
60.
60.
Yeah. Okay.
Did you guys get that as well?
Yeah.
Yeah.
Okay.
I'm just trying to look at my notes. Thank you.
Gotcha,
Okay.
girl.
So question number 8, that will go back to me. What condition is required to induce thermionic emission within the cathode filament? Oh, this one did stump me, but I believe it's high current.
I think it is too.
I
Yeah, I
was
think so
for
too.
some reason wanting to say direct current, but I know the thermionic emission is like you're boiling up or boiling off the electrons, so it makes me think like in order to boil, you need like a higher temperature. So I don't know.
Oh, that makes sense.
Yeah. Okay, number 9. We have this lovely graph. Want to take a stab at it, Willie?
Let me see. The following graph is the photon energy spectrum for an exposure created with the technique of 80 kVp and 10 mass using a tungsten anode. What portion of the graph represents K-shell characteristic photons? I think I got this one wrong when I did it. Because I picked B.
I want to say it's C because that's the only part of the graph representing characteristic.
Yeah.
Because B would be like Bremsstrahlung since you see like a lot more of that.
Okay.
So I
Yeah.
want,
We'll go with C.
hopefully.
I think that's right. Yeah.
Okay.
Right, nice work. Heidi, number 10, please.
Which component of the X-ray tube becomes negatively charged during an X-ray exposure? It would be the cathode filament.
Alrighty, Viviana, we have this graph now.
Okay, the following graph is the photon energy spectrum for an exposure created with a technique of 80 kVp and a 10 mass using tungsten anode. What is the approximate energy of the photon at position C of the spectrum? I don't really know how to answer this one, but my mind just automatically goes to 69 because of the tungsten. I think it was like 69. So that's, I don't know. I don't know if I'm right or wrong on that one.
I
Or
think
we-
it would be 80
Yeah.
because the
80?
C is the characteristic.
Okay.
So I believe, I'm not sure.
Well, for
But
me,
since
I think of it as like 80 is the peak and the approximate energy the photons reach is 80.
Mhm.
So that's just the way my mind goes to 80.
Okay.
I
Mhm.
think I would be careful on this one.
It's talking about C, which is characteristics, and that's technically like 69. I want to say it's 69. Because when it's talking about C in the graph, it's talking about characteristic, and when they talk about characteristic, they talk about like the tungsten binding.
I don't think I just quite understand it. So let's just, how many say 69?
Me, but I don't know.
I would say is, yeah,
Same.
69 as well.
So 3, 4 people?
Yeah, just because
Yeah.
on the last one, I'm pretty sure we said, or
Okay.
Anne was saying,
Uh,
just, yeah.
let's see.
I
Oh,
think
it is.
it is,
Let's
yeah.
see
Yeah,
why.
there
It
you
says
go.
location represents the character's photon within the photon energy spectrum. Character's photon is a location as the energy of the about
Oh, that's-
69 kilovolts. I still kind of feel like I don't understand why, but
Good
it's just
job.
tungsten. I remember it was 69, so that's
That's
it just-
right. That's right.
that's the only
I
thing I
got
could think of.
confused.
It's all right. That's why we have each other.
Okay, Jessica, are you next for 12?
Sure. I think it was Angela, but it's okay.
Oh, wait, sorry, and you're going next.
During an X-ray exposure, an incident electron strikes the anode with an energy of 84 keV and passes very close to the tungsten nucleus. What is the approximate energy of this electron as it exits? I know there was one that was like when it's really close, like it decelerates a lot. So I can't remember if it's 1 keV. No, it seems really low too. I don't know if you guys have this.
I think you're
I
right.
think it's one. Yeah,
Yeah.
Yeah.
Yeah, I think it's one too.
the lowest ones.
Okay.
There you go.
Okay, Jessica, are you next?
Yeah. The maximum energy of Bremsstrahlung photons is controlled by which technical factor? I think it was to current or to potential. I think it's potential.
I think it is potential.
Yeah.
Yeah,
Potential or
right.
potential. I don't know. Okay, good.
Yeah, because I think tube potential or KVP is like what will control that energy. Danae, are you next?
I think so, yeah.
Okay.
Bremsstrahlung is a German term defined as braking radiation.
Okay. And then next is me. So what technical factor is primarily responsible for controlling the energy of the X-ray beam? This one is also a kilovoltage peak. Willie, you are next.
All right. Electron binding energy is defined as the energy of attraction between orbital electrons.
It says
Energy
energy required to move an electron from orbit.
That's so confusing.
I know they're all kind of like
When I think binding, I'm thinking attracting.
Me too. Yeah.
Makes sense.
Yeah. Sorry, my order keeps going out of order. Is it you,
It's
Heidi?
me. Yeah. Okay. What are the majority of X-ray photons in an X-ray beam classified as? Majority, I believe it's Bremsstrahlung
Mm-hmm.
radiation.
Mm-hmm.
Nice.
Alrighty, and then Viviana.
The maximum energy of Bremsstrahlung, a photon that can be created during an X-ray exposure, is equal to energy of the incident and binding energy application, binding energy of the electron. I want to say it's the energy of the incident electron.
Think so
that-
too.
Is that correct?
I think so.
Mm,
Think so too.
Let's try. Nice. I wasn't sure about that one.
Okay, and then Angela.
Says how much energy is required to remove a K-shell electron from a tungsten atom, and I want to say it's 69.5.
Yeah, I just have that memorized.
Yeah, that number.
So that was called the binding energy, apparently. And then, yeah, so for example, here's all the binding energies listed in this next question. There's the K shell, that's a 69.5. And Jessica, this one is yours.
What photon energy is produced by a tungsten anode if a K-shell electron vacancy is filled by an M-shell electron? The approximate electron binding energies for tungsten are as follows. So I would take, it's the K shell minus the M shell. So I would say the 66.5 kV.
I agree. Okay. Wonderful. And now it's Danae.
During the process of characteristic X-ray production, the cascade effect refers to the this is the electron transfer from the outer shell to the inner shell.
Okay. And then 22, that goes back to me. The energy of a Bremsstrahlung X-ray photon is equal to, I believe this is the difference between the incoming and the outgoing electron energy.
I think so.
Yeah, I
I
agree.
think
That
so
was the
too.
one that I had trouble with in the beginning. It was, remember, it was like the subtract the numbers, right?
Yeah.
Yeah.
All right, Willie, number 23, please.
Which component of the X-ray tube serves as the source of free electrons? That is the cathode filament.
All right, Heidi, you're next.
Okay, consider this scenario. An exposure of an obese patient results in inadequate receptor exposure. What technical factor should be modified to increase the energy and penetrability of the X-ray beam? I would say it would be KVP because of
I agree.
penetration.
Yep, I just think of penetrating power as KV.
I'm gonna think of that tennis ball from now on.
Yep. Okay, 25, that is Viviana.
Okay, consider this scenario. A portable chest X-ray demonstrates excessive exposure. How can the technologist decrease the intensity of the X-ray beam while maintaining the same beam energy? I would say decreasing the the MA.
Yeah, good. Just because I always think energy, we had that question earlier. The
Mhm.
energy of the beam is KV. And we want to keep the same beam energy. So we'll keep the KV the same. And you're saying to decrease the or sorry, decrease MA? What'd you say?
Decrease MA.
Yes. Okay. We'll try that. Okay, wonderful. Angela, you're next.
An exposure taken with an 80 kilovolt peak would have an X-ray energy spectrum with a maximum photon energy of, it would be 80 keV, I think. Yeah.
Good. Jessica, you're next.
Bremsstrahlung radiation is created within the X-ray tube when high energy electrons interact with which of the following? That would be the electric field of the nucleus.
All right. We're almost done, guys. Danae, you are up next for question 28.
What name is given to the innermost electron shell within an atom? That's the K shell.
All right. I'm next. During an attempted X-ray exposure, the X-ray tube fails to create any X-ray photons. Which of the following conditions is most likely to explain this failure? What did I say? Oh, it is the breakage of the cathode filament.
I agree.
Mhm.
And then Willie, you'll be last for question 30.
Characteristic photon's energy depends on which two of the following variables? It is the energy of the incident electron and the binding energy of orbital electrons.
See how we did. All righty. Pretty good, guys. And then I think that question 16 we were able to correct. Does anyone have any other questions in regards to this X-ray production module in Clover Learning, or anything that kind of stumped you or you wanted to touch base on?
I think I need to go over the whole Bremsstrahlung thing again, or maybe it's the characteristics, because those bar graphs are kind of confusing to me.
Yeah, I think I just need to rewatch the videos.
Mhm.
The what was confusing to me was the one where it's like when it gets closer to the nucleus, it decreases in energy. I don't know. Those there was like three questions that were kind of similar that kind of threw me off a little bit. Like the one where it was like 1 keV and then
It was like 110 or something.
yeah,
Even though they're both like near the nucleus, they were
Mhm.
kind of different.
yeah.
Yeah.
Mhm.
And then that question too, with the whole like binding concept, the binding energies are all different for the different shells, and binding doesn't always mean like attracting or coming together. It also can mean like removing an electron from like the K shell or something else. So yeah, it's just, I think certain things just need to, I think, get reviewed more and more. Just it's like repetitive stuff that we just probably gotta memorize.
Yeah.
Alrighty, I think we can just wrap this up and stop recording. Good work, guys.